Okay, so in this video what I'm going to do is I'm going to show you how to show that various properties have been conserved in interactions or in decays. So say for instance we're going to look at beta plus decay and show that some things have been conserved. So the first thing to do is write out the equation for that decay. So in beta plus we've got a proton, it goes to a neutron, positron, and also an electron neutrino. So let's say we're going to look at charge. So the way to set this out is to link a number to every single particle, so you set it out in the same format. So the charge of a proton is obviously +1, so you put +1 under there, and draw your arrow across. The charge of a neutron is, well, it's neutral, so that would be 0. The charge of a positron is obviously +1, and obviously the charge of a neutrino, neutrino gives away, can I give away? It's going to be 0. Okay, so the next thing you do is you consolidate both sides, so you gather all the terms together, and you've got 0 plus 1 plus 0 gives you +1. So the last thing to say is charge is the same on both sides, so charge is conserved. And that's the way you set these things out. So first thing, you write the equation, step 1, write the numbers for each property underneath each particle, so like in the second row, then gather together the terms on a final row, and then a statement saying whether it's been conserved or not. Okay, so let's try it for a different property. So I'm just going to make some blanks in there. So then, okay, so instead of looking at this, let's look at one of the other properties that has to be conserved. So let's look at baryon number. Okay, so a proton is a type of baryon, so it still will have a +1 number there. A neutron, however, this time, a neutron is also a baryon, which means that will have a +1. If we go across to here, an electron is a lepton, so obviously it has 0 baryon number, and then an electron neutrino is obviously a lepton too, so then you end up with 0 from that one. Gathering the terms together, you get +1 and +1 again. So just like before, so it's the same on both sides, so baryon number is the same, and so baryon number is conserved on both sides. And obviously we know that beta plus decay happens, so you'd expect the electron lepton number and the muon lepton number, the baryon number, and the charge and that sort of thing to all be conserved, because it can happen. If you prove that any of these things aren't conserved, then that means that that's a decay or an equation or interaction that can't actually happen.